Object change their velocity. And draw the diagram and write down the Buddha how to write the acceleration. Right, finish. Final velocity minus initial velocity means change in velocity. The change in velocity divided by time equal acceleration. Any quantity divided by time means the rate. Right? No need to remember the definition, but just think any quantity divided by time is rate. The rate of change of velocity is acceleration. Right, Buddha? Finish?
Yes, sir.
Right. Now, we move to the example. A car is traveling at 20 meters per second. It accelerates steadily for 5 seconds. After which time is, after which time it is traveling at 30 meters per second. Calculate its accelerations. Now, the values are given for initial velocity, final velocity, and time. Right? This example, initial velocity equal 20 meter per second, final velocity equal 30 meter per second, time equal 5 seconds. Right? Now, the equations for the acceleration, v minus u divided by t, then equal final velocity 30 minus initial velocity 20 divided by 5. 30 minus 20, 10 divided by 5, then 2. 5 divided by 10 divided by 5 equal 2. The difference is meter per second divided by seconds. Then s equals numerator per seconds. S minus 1, S minus 1, S minus 2. What is the simplification? Right? Or meter per second divided by seconds. This seconds goes to denominator m over square seconds. Then again goes this way, m s minus 2. Right? You have to know these simplifications. Is it clear?
Yes, sir.
Right, good. Then finally, acceleration equal 2 meter per square seconds. Right, or 2 meter square seconds. Both are correct by writing the units. At home, write down the example 2. Right? The questions places 2 rules to write the example and write down how to simplify. If you have doubt, please send message. Right. Right, Puta, finish.
Yes, sir.
The next one, if the velocity increases with time, that is an acceleration. Right? This example. Now, velocity decreases with time, that is a negative acceleration or deceleration. When velocity decreases with time, the example, now take initial velocity 40 meter per second. After few minutes, the velocity becomes 10 meter per second. Then velocity decreases during the 2 seconds. Right? Then what's the equation for the acceleration? Final velocity minus initial velocity divided by time. Final velocity 10 meter per second minus initial velocity 40 divided by 2 seconds. Then 10 minus 40 means minus 30 divided by 2 seconds. Then minus 15 meter per square seconds. That's a deceleration. Negative acceleration is negative. The negative acceleration is deceleration. Is it clear?
Yes, sir. It's clear.
Right. Do right. Okay. Write down some note. If the velocity decreases, with time, it is known as It is known as negative acceleration. Negative acceleration or a deceleration. Or decelerations. Right?
Yes, sir.
Right. Write down some example. We write the same example like an object moves. Right. The object moves along a straight line from capital A. From capital A. With with 40 meter per second. 40 meter per second velocity. Next rule or push-up. Time is 2 seconds. The time is 2 seconds. And velocity at B. The velocity at B is 10 meter per second. 10 meter per second. Find acceleration. Find acceleration. And draw the sum diagram. Right. In a question, this is an accurate method, right? By drawing the data, and you can understand quickly how to do questions and what are the values, initial and final. Right? Finish with that.
Yes, sir. Finished.
Right. Right. Now the example 3, right? Read the example. An object hit the ground traveling 40 meter per second. It brought to rest during the 0.02 seconds, right? Then when object hit to the ground, we can assume means the final velocity is 0, right? No bounces. The time is 0.02 seconds. What is the acceleration, right? And mark the values with that and write that questions. Right, the initial velocity is 40 meter per second. Then final velocity is 0. The time period is 0.02 seconds. Right? Using these steps, quickly calculate the acceleration. In the previous questions also, you can write like this. The previous answer is minus 15 no, Buddha. In the previous example,
Yes, sir.
right. Then you can write in the previous example, the acceleration is negative value. Therefore, it has decelerations like that. That's the important thing. Then you remember the negative accelerations is equal deceleration. Right, Buddha? Right? Puta means dua and puta both are puta viga. Right now? Okay. Right. Right. Yes, sir. Then again, the acceleration equal change in velocity over time. The final velocity is 0 when object hit with the ground minus initial velocity 40 divided by time 0.02. The simplifications minus 40 divided by 0.02, right? There are two decimals now. You can multiply by 100, then 0.02 become 2, right? Minus 4,000 divided by 2 means minus 200. Yeah, 10 minutes. 10 minutes, 1 seconds. And finally, minus 2000 m is minus 2. Right? Here also you can write accelerations is negative, therefore it has deceleration. Right, Pudha?
Okay, sir.
Right. 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 I think conversion initial t equals 0. Velocity also 0. During 1 seconds, velocity take 2 meter per second. During the second, 4 meter per second. During the third second, 6 meter per second. Then we can plot the graph velocity versus time. The time is second, velocity meter per second. Right? And mark the values. Time 0 during 1 seconds, during the 2 seconds, time 3 seconds. Velocity 2, 4, 6. Mark the values, you know how to mark. 2, 4, 6. Right? Then during 1 seconds, velocity 2. Mark the value. During the second seconds, velocity 4. During the third second, velocity 6. And you can plot the graph. Right? Draw the line, best speed line. This is the line. Right? The straight line passed through the origin. Right. This velocity time graph. Then theta is angle. Then what's the theta? Angle. And you have to know what's the gradient. Gradient means the y coordinate difference or x coordinate difference. Remember that?
Yes, sir.
Right? Or there's another method, tan theta, no? Y coordinate difference over x coordinate difference. Sorry?
No, sir. I just said X coordinate difference.
Okay, Buddha. Or tan theta, right? Both are correct to calculate the gradient. Now, the y coordinate, the y2 take as a 6, y1 take as a 0. Or you can take any values. Then corresponding x2 for the y2, 3. Then x value is 0. Then the gradient equal the y coordinate difference. 6 minus 0, right? Unit meter per second divided by the time 3 minus 0. 6 over 3, 2 unit meter per square seconds. Now you can see the unit equal, what's the unit? Meter per square seconds. Meter per square seconds means the unit of acceleration. Therefore, you have to know the gradient of velocity time graph gives acceleration. Right? Is it clear?
Yes, sir.
Good. Daughters. Right. Okay. These are you have to remember. Now we put a small note. Right and put a velocity time graph, right? This is fast track mode, therefore, this is a summary, right? And you have to know these points. Right and Buddha. When the variation of velocity, write down, when the variation of velocity of an object moving along a straight line is plotted. Am I fast? I repeat again. When the variation of velocity of an object moving along a straight line is plotted against time. A velocity time graph is obtained. Right. Right. Now complete this. First, draw the velocity mark during the time intervals and plot the graph and calculate the gradient. Right, Buddha?
Yes, sir. Finished.
Right. Then next to write down the area covered by the graph. Right. Right. Now, what's the area covered by the graph? Area. Right. How to calculate the area of the triangle? You know, half base into height, no? In a triangle, when you scale like that, then multiply now here 4 and 2, then area equal 4 times 2. In a triangle, half base into height. The base is 3 seconds. The height equal 6 meter per second. Then per second, second cancel. 6 over 2, 3. 3 times 3, 9. 9 meter. Then unit is meter. You know, meter is a distance of, meter is a unit of distance. So remember, the area covered by the graph equal distance or displacement. Right? Is it clear, Buddha?
Yes, sir. Clear.
Right. Write down next rule. The area covered by the graph. The area covered by the graph. In a velocity time graph, in a velocity time graph, represent the displacement of an object. I repeat again, the area covered by the graph in a velocity time graph represents the displacement of the object. Right. These are important in a velocity time graphs. Now think in a VT graph, velocity time graph, is the above area is S1, the below area S2, right? Area S1 and S2. Then we have to calculate displacement. Now we know the area of displacement time, the area of velocity time graph equal displacement. Now what? In there's a positive area and negative area. Right? How to calculate the displacement? By adding S1 plus S2 or S1 minus S2. According to your knowledge,
Yes, sir.
right? The displacement equal S1 minus S2. You have to subtract because this is a positive area, means the object's moving the one direction, no? This way. The negative area means the reverse motions. Then to calculate the displacement, S1 minus S2 is displacement. Is it correct?
Yes, sir.
Right. The distance equal S1 plus S2. Right? Put some small note, is important in the questions. Right, Buddha?
Hold on.
Right.
Okay, sir.
Right, Buddha. Now we got some examples to understand the velocity time. Now, in VD graph, right. Now, the horizontal angle, the theta is constant in this graph. Then tan theta gives the acceleration. Then the angle make with horizontal is constant or varying with the time. Constant, no? This horizontal angle is constant, no? Is it clear?
Yes, sir.
Right. Then the gradient is constant. Gradient constant. Right? The gradient equal accelerations. The gradient equal accelerations. Therefore, the acceleration is constant. Right? And next important thing, this gradient are positive, this gradient are negative. Do you know that one? In a graph, your knowledge, previous knowledge, when angle
Yes, sir.
make it small angle, acute angle, the gradient positive. Obtuse angle, gradient negative, no? Do it? Right? Do you know this one? For the graphs, important. Right. This gradient are positive, this gradient are negative. Right. For this example, gradient constant, therefore acceleration is constant. Right? Positive acceleration. Write down to that.
Okay, sir.
Right. Next one. Velocity time graphs. Now there are two lines. A, the second one is B. Right? Now think and write down about A and B. What are the differences in A and B graph? Which has high gradient, A or B?
A.
A, because in a B graph, the angle is this one. No? But for graph A, angle is this one. Graph A has a high angle with horizontal. Therefore, gradient is high in A than B. Therefore, accelerations of A is higher than B. Right? When gradient is high, acceleration is high. Object A has high accelerations than B. Right, Pudha?
Sir. Yes, sir.
Right. Draw the graph and write down. Gradient is high in A graph. Therefore, acceleration is high in the A graph than B. Right. I explain again. Now, in graph B, now think angle. Right. Now, in a B graph, now think angle is 30-degree, but A angle with the horizontal may be 60-degree. Right? The gradient equal tan value. Now tan 30 equal 1 more root 3 for the B graph. For the A graph, the gradient, now acceleration is acceleration equals gradient. The gradient equal tan values to for the B graph. For the A graph, accelerations for the A graph equal the gradient tan 60. The tan 60 equal root 3 ms minus 2 ms minus 2. Right? I take small example right there. Angles are not given for your questions, but you can mark 30 and 60-degree with horizontal. Right? Then row 3 is higher than 1 or row 3, no? Is it clear now, though? No, can you understand or do you need another explanations? Right? The angle with horizontal in A graph is higher than B. Gradient is high in A graph. Therefore, acceleration is high. Now, can you understand? Tua? No, it's okay.
Okay, sir.
Right. Right. Now, we move to another example. Right. At these situations, velocity is constant, no? Right? When object move with constant velocity or with a uniform velocity. Write down next example. Draw the graph and write down the velocity is constant with time. Then object move with constant velocity. Right?
Yes, sir.
Right. Now, so this graph also, the blue color one. Right. Here also gradient constant. This horizontal angle is constant, but it has negative gradient. Right? The gradient is constant. The gradient is negative. Right? Gradient equal acceleration. That means acceleration is negative. Negative acceleration is deceleration. This is a real process of constant deceleration. Right? I repeat again. The blue color graph. Gradient constant. How to identify gradient constant? Draw the line like that and mark, right? Now think, draw the line and draw line. Angle, mark the angle line. Then this angle is constant. Now think the differentiate of the graph like that. Now this angle is not constant. Its angle increases with time. Therefore, gradient increases. Gradient increases means acceleration increases. Right? This graph. But this graph, gradient constant, gradient equal acceleration, but acceleration is negative. Right? Due to gradient is negative, therefore object is moving with constant deceleration. This graph. Is it clear, Buddha? Right? First describe this graph. It has negative gradient. Therefore, negative acceleration. That means deceleration. Object move with a constant deceleration because the angle is constant. And mark this graph also. The gradient is positive in this line because less than 90 up this angle, acute angle. But the values of angle increases. Therefore, the gradient increases. Right?
Yes, sir. Understood.
Right. Describe this graph also. Right? Gradient increases, therefore acceleration increases. Right, Buddha?
Yes, sir. Finish.
Right. Right. Now, think the object start with velocity u. The initial velocity is u. It has uniform acceleration or constant acceleration. During the simple t times, it gained final velocity v. It has displacement s. Right? The object start with initial velocity u, final velocity v during the time t. Right? It has displacement s. Right. Right, Buddha? Write down subtopic. Write down subtopic. Equation of motion. Write down subtopic. Equation of motion for uniform acceleration. For uniform acceleration. And draw this diagram and we explain again. Let's draw this one. Then write down let capital V, let capital V be the final velocity. Be the final velocity of an object whose initial velocity is u. Which has traveled for a period of time simple t. I repeat again. Let capital V be the final velocity of an object whose initial velocity is u, which has traveled for a period of time simple t with a uniform acceleration of simple a. Right? These are we apply for the constant acceleration or constant deceleration motions only. Right? Remember that one. We already know acceleration is equal final velocity minus initial velocity divided by t. Right? So rate of change of velocity equal acceleration. We know. We have done these things. The next step, cross multiply when a times t equal a equal v minus u. Then substitute the v minus u goes to left side, become plus u. Then finally v equal u plus at. It's the first equation of motions. Got it, Buddha?
Yes, sir.
Right, write down.
Okay, sir. Finished.
Right. There's another equations in equation motions, but don't need to how to prove. I can show that the proof, but the next equation v square equal u square plus 2as. As an AC equations, final velocity square equal initial velocity square plus 2as. Final velocity square equal initial velocity square plus 2as. Right, Buddha? Write down these equations also.
Okay, sir.
Right. Then we move to the page number 15, example 5. Right. First read the example 5. Don't look the answers. Right, Buddha? Right. Now, read the example 5. Right. Then identify the values. The cylinder contain machines is dropped from the helicopter at a height of the 200 meters above. Then the height is displacement. Displacement is 200 meters. The accelerated to gravity. The acceleration speed is A equal 10. Calculate the speed at which cylinder will hit the ground. That means you need to calculate the final velocity. The object start with rest. Right? We assume the initially object is at rest. Then apply these equations. V square equal initially 0. Still no need to write the 0. Right? If you want, right, we can write 0, but it does not write. 2 acceleration equal 10. The displacement equal 200 meters. Then 400, 4,000. V square equal 4,000. The square root of the 4,000. Using the calculators, we can, the answer is 63.25 meter per second. This is a final answer. Is it clear, Buddha?
Yes, sir. Finished.
Right. Right. Can you rate these questions?
Sir, can you zoom in a little bit?
Sorry, Buddha?
Sir, can you zoom it a little bit?
Okay. Now,
Okay, sir, now it's fine.
right. Given here, the velocity time. But notice are not talking, no? Right? It is clear? Right. Describe the motions during the OA. Now from O to A to B, and B to C. Right? Now try this one. I send these dudes. Right. First, describe. Wait, Puta, before the questions we move. If you can open the, I have sent the tute, the next tute. A toy car rolls down a ramp and hit the cushion. The graph shown the right. Try the question number 1 and 2. It is easy. Right? Answer for the question number 1. Right, Putta, what's the answer for the question number 1? Right, this one. I have sent you. A toy car, right? These are examples on your Excel. The toy car rolls down, ramp, and hit the cushions. The constant velocity. ABC. What's the answer for the first one? Then try 1, 2, 3. Right, good. Do it.
So constant velocity is shown at the horizontal part of the line, right?
Yeah, correct.
Okay, sir.
That means this constant velocity, no? Then
Yes, sir.
answer is B. The question number 2.
So it's shown by the area under the line.
Right. Distance means the area under the line, no? We have discussed this area equal distance. Right. The third one, average velocity of the toy car is given by. How to calculate the average velocity?
So the distance moved divided by the time taken.
Yeah, the distance moved divided by the
Divided.
time taken.
Mhm.
Right. Right. In this question, what's the acceleration of the ball? Right, calculate the acceleration, Sudha. This value is 5, 10, 15. The times 1, 2, 3, 4. And find the accelerations here. Question number 5.
The answer is 7.5 meters per second square.
Right.
So 7.5 there.
Positive or negative?
Positive, sir.
Why?
Wait, hold on.
Right. Now, this gradient is negative this way. Right. This type graph gradient positive. This graph gradient negative. Then how to calculate the gradient? Here 15, 0. Now, the gradient equal 15 minus 0 over corresponding 15 coordinate 0, no? 0 minus 2, right? Then 15 over minus 2 minus 7.5 meter per square second. Is it clear, Pradhan?
Yes, sir.
Right. Right, good. Using the graph, what is the total distance traveled by the ball? Now calculate the total distance. Right? Total distance, not the displacement, right? Then the difference of the area of addition. Right? Then calculate the area. Right, Putha? This triangle R base is 2, height 15 plus area of this low area triangle R base 4 minus 2 is 2 again, height also 15. 2 cancel, 2 and cancel. 15 plus 15, 30. 30 meters. Yeah, do. Buddha. Addition of the area, correct. Because distance, no? Good. Right. Question number 7. Quickly gives answer. Moving object has uniform non-zero acceleration. Which velocity time graphs correctly show this?
So uniform acceleration.
Every
Uniform acceleration.
Moving object has uniform non-zero accelerations. Yeah, uniform. Yeah.
C, sir.
Sorry.
The answer is C, sir.
Object has uniform non-zero acceleration. In a C, look at in C, velocity is constant, no? In a C graph, velocity is constant, no? That means acceleration is equal in a graph C, V minus V over T. That means acceleration 0, no? Non-zero, non-zero acceleration, Sudha. Non-zero means object has uniform non-zero. Now look at graph C. There's an angle. The angle is, or the gradient is positive, right? And gradient is constant. That means there's a uniform acceleration. But here, gradient increases, right? Acceleration increases. Then what's the answer? A. Am I
Yes, sir.
correct?
Yes, sir.
Do I can't remember. What are the name? Got it though. The answers. Okay. Now, in this question, the displacement time graph of an object shown. Which of following is the corresponding velocity time graph? Right? Right. Now think you have to translate or convert displacement time graph into velocity time graph. Using displacement time graph, we have done last day. The object is start at rest. Or is there any is there any velocity at the beginning? Right? Now initially look at, is there any gradient? There's an angle, no? At the beginning. Right, Buddha?
Yes,
Then
sir.
object is start with a certain velocity. Then what's the gradient? increases or decreases? Decreases, finally, zero, no?
Yes, sir.
And displacement decreases means the direction is changing. Object moves, the initial object move this way, and after that object move this way. Object is reversed. The direction is reversed. Right? Then what's the answer? Right? Cannot be, because the direction must be changed, right? A and C you can cut. Why? According to displacement time graph, here displacement increases. That means object move this way. The other half, object turn back. And final displacement zero. Right? Initially there's initial zero, displacement increases and decreases, final displacement zero. Then which answer is correct? B or D? That's the correct answer. Initially gradient positive or negative?
So initially it's positive, right? Because it
Positive
increases.
gradient, no? Then what's the best answer?
D, sir.
D. Lotus got it this answer. If not, I can explain again. Because initially this gradient is positive. The gradient equal velocity, it has positive answer for only D. That's why answer is D. Good. Right, next questions. The initial accelerations. Now graph is velocity and graph. How to calculate the initial acceleration? Now think, take 2 minutes. Right. Right. Finish, Pata.
Hold on,
Initial
sir.
acceleration. Right. The initial acceleration from here to here is acceleration constant. Then calculate the gradient. Y coordinate difference or X coordinate difference. Y coordinate 3 minus 0 over 6 minus 0. This is the acceleration. 3 or 6 means half. That means 0.5 ms minus 2. Right, Buddha?
Yes, sir.
Right now, you have to do the questions at home. The questions in page number 15, 16, 17 questions. Right. You have to do the questions. And next day, we move to forces and shape parts. Quickly we finish. Uh, if you can't understand, please send a message. Then I can do the class at slow than this time. I think you can understand these things, no? If you have doubts, please send message. Now share our class details for your friends, right? Then we meet next day, next Monday at the same time, Kuta. Right, okay. Good night.
Okay, sir. Thank you, sir. Good
Right,
night, sir.
Kuta.
Thank you, sir.
Right, thanks. Right,